Good morning, ladies and gentlemen. It is still morning here in Silicon Valley. Cloud Expo, 9th Cloud Expo, day 4 now, but we're still serving up content, which means we must be with Henry Fastert next. Chief Technologist, no less, a managing partner at SHI. Let's give it up for him and see if we can crack this myth or reality question. Henry, I'm interested to see
Thank you, Jerry.
the answer to this
Appreciate
one.
it.
They're applauding without a cue. I like that.
Well, good morning, everyone. I think a lot of people here probably know SHI as a large-scale VAR and provider of professional services to the IT industry. But 18 months ago, we decided to make the move to become a cloud provider as well. And so it is a logical extension of the products and services we've provided to the industry over the last 22 years. But we decided that we wanted to target an area of cloud computing that has not, quite frankly, been very well served. So our offering is based on is an infrastructure as a service offering, but it is targeted specifically at production applications, including mission-critical applications. And so what I wanted to share this morning were some of the criteria, some of the things that we, our thought process that we went through to provide the kind of cloud that people would be comfortable with from a production application point of view, including a mission-critical point of view. And so I think everyone has seen this slide one time or another, or maybe 100 times or another. I only bring it here today just to reinforce that the part of cloud computing that I'm going to address these issues is around infrastructure as a service. And so, again, I think everyone here, you're here for the reasons that are on this slide. We understand the value of cloud computing, the things it brings to us, and the value it brings to us from our, not only from an IT point of view, but from a business value point of view. But none of these things are of particular value if you can't put production applications into the cloud and put them into a cloud that you feel comfortable in having production applications in. And so, if you look at, typical first-generation cloud providers in the infrastructure as a service space, there are 3 areas that people always have questions and concerns before they would put production applications or confidential information. So security, how secure is this environment? How can I be sure that my information stays my information? And so we'll speak to that in some detail. Connectivity. Most first-generation clouds, connectivity is provided over Internet 1. And so there are a lot of limitations in terms of what you can do from a bandwidth point of view and a latency point of view, both of which can be critical to production applications. And then finally, how resilient is the cloud? How comfortable am I that this infrastructure that my applications is going to run in is going to be available to me 24/7? So, from a security point of view, all of these things become, important issues. And when you look at cloud providers, these are the kind of questions that, and that you really need straight answers from. From perimeter security all the way down through data security. And so, the perimeter security, a lot of these things are conventional from a security point of view when you look at standing up your own infrastructure in your own centers. But those exact same paradigms need to be applied by your cloud provider if this is going to be a useful infrastructure as a service for you. And not the least of which is data security itself. And so, in most cases, first-generation cloud providers do not secure the data in any meaningful way. The data is not encrypted in their centers. You have no way of knowing if a service tech comes into a cloud provider's data center and replaces a disk drive, whether your information is going out with that. And so that creates a lot of challenges in terms of using first-generation cloud providers because you have to provide for all of that. You have to make sure your data is encrypted. You have to take care of all of that on your side and still walk away with concerns about, is the security really there when I need it to be there? Certainly connectivity. I mentioned earlier that, again, first generation cloud providers typically provide internet connectivity. Well, because of the bandwidth restrictions and maybe even more importantly because of the latency restrictions associated with internet, one, there are lots of production applications that are simply not going to run in that environment. You have to be concerned about the security of all those things. And most importantly, you have to be concerned about the availability of all of it. And so, it's not designed to be industrial grade. It's not designed to be resilient. And so, along with the parameters of bandwidth and latency, you always have to be concerned about the availability to your site. I'm trying to say the best way to say this is from an adoption point of view, from the things that you're looking for in a cloud. These are critical capabilities: availability, performance, mean time to repair. All of that impacts, the resiliency of your cloud. Is that infrastructure designed to host mission-critical applications? Are there single points of failure associated with it? How sure can you be of the performance associated with your cloud? And not only the performance at any given moment, but over time, what are the variances in performance? Because applications that might work well, in 1 minute may fail or work very poorly in another. And so all of these things, including the mean time to repair the infrastructure. So if the infrastructure includes single points of failure, well, then you have to be concerned about how long it's going to take to restore that infrastructure if one of those single points of failure goes bad. And so these are the things I think that you need, to demand from a cloud provider if you're going to put production applications into the cloud. You have to demand a very secure environment. Now that sounds obvious to say, but there are 3 different types of security that you really need to be sure that are in place if you're going to put production applications into the cloud. One is what we refer to as structural security. And so, an example of structural security is, can the cloud provider project the virtual machines onto your network, as opposed to you having to use virtual machines in the cloud provider's network? If the cloud provider can project virtual machines onto a segment of your network, well, then those virtual machines, use your IP addresses. The cloud provider can't see inside of those virtual machines. And so it provides an element of structural security. It also provides an element of usability. If the virtual machines are placed on your network with your IP addresses, they become indistinguishable from your own virtual machines. So it becomes very easy to build application deployment architectures either solely out of those virtual machines or out of combinations of your own virtual machines, your own physical machines, or potentially virtual machines from multiple cloud providers. So if they all appear on your network, it provides an element of structural security, but it also it significantly improves the usability of infrastructure as a service. From a performance point of view, you have to be sure that, one, at any moment in time that you're going to have the performance necessary to run your applications. And so the questions you need to ask is, what is the oversubscription rate that your cloud provider is using? It is not unusual for cloud providers to use an oversubscription ratio of 10 to 1, meaning 10 virtual CPUs to a single CPU thread. And so, one, at that level of oversubscription, you can never really be sure what performance you're going to get from that virtual machine at any given time. And so, a low oversubscription ratio that the cloud provider guarantees to you, is a very desirable characteristic when you're selecting a cloud provider. Other areas of performance, what does the networking look like in terms of how you can attach to the center? If your provider only provides you internet connectivity, well, that's going to fundamentally limit what you can do. And so a cloud provider who's going to host production applications needs to be SONET attached. needs to be able to offer MPLS connectivity, Metro Ethernet connectivity, be able to offer very high bandwidth at very low latency, so that you have not only the bandwidth, but because of the low latency, a predictable experience in how your application is going to run. And then finally, while lots of cloud providers don't like to talk about their infrastructure and how it's put together, that's a critical question for you to ask. What does that infrastructure look like? How is it built? Are there single points of failure in it? Is it designed to be redundant? If you're going to consider putting production applications into the cloud, well, the answer better be that this is a redundant infrastructure, that there are no single points of failure anywhere in this infrastructure. Because if there are, well then how often your application will be impacted is anyone's guess. I think these are the type of services that you would expect from a cloud provider, again, who's going to provide you a production quality cloud. So, the typical self-service, the portal that you're going to, provision virtual machines, that's all, that's, while typical, even there are nuances from a production quality cloud. So, for example, there should not be restrictions in the combinations of CPU and memory that you can use. You should be able to tailor that specifically to your application. There shouldn't be lock-ins in configurations that, for example, typically require you to provision more CPUs than the memory that's in that package can support. And so you need to have that kind of flexibility. You need to be able to select tiered storage. As a minimum, there needs to be at least 2 tiers of storage performance offered, and preferably 3, so that you can tailor the performance and the cost of your storage specifically for your production applications. And so, in addition, the portal itself needs to be exposed exclusively to you. A worldwide web-facing portal is an inherent security risk. And so that self-service portal not only needs to have those characteristics that I just described, but each individual customer needs to have their own version of that. And that version is not exposed to the World Wide Web, where anybody literally, obviously, in the world can attempt to hack it. Time box computing. Lots of people who are dealing with production applications need to deal with seasonal changes in demand. The perfect example is the 1-800-Flowers model. This is a company that does 95% of its business in 2 weeks of the year, and so to be able to properly use burst computing, again, you have to be assured of all the other things that I just described, that this is going to be available to you. It's going to be not only available when it's been requested, but is going to provide the performance that you expect. You have an absolute right to get exactly the same performance each and every time that those additional virtual machines are spun up for you. Because if you spin up virtual machines and all of a sudden the performance isn't where it needs to be, well, then you're going to have issues from a burst computing point of view. And then finally, the cloud provider needs to provide sufficient quality that you can use their center as a failover target for your applications. So even if you've not moved your applications into the cloud, you have reasons that you prefer to run them on your own infrastructure, they should have the capabilities and the service available to you to allow you to use their center as a failover target. Another important element of all this is how the service provider has structured their data centers. The ideal model to do this is something that's called service cores. A service core is a finite collection of server, storage, and switching elements, generally both fiber channel and IP, that the provider will replicate over and over and over again to expand capacity. In addition, a provider who has a service core based design in many cases can also extend those service cores so that a service core could be placed in your data center. It's still managed by the provider, it's still owned by the provider, it provides virtual machines through the same portal and through all the same mechanisms, but it can physically be on your site. Many companies have compliance and regulatory issues that require their data not leave their site. And so a service core based design provides splendid isolation, inside the data centers. It provides another layer of resiliency and performance around that, but also allows a very flexible deployment model. This is an example of a service core. Again, it's a finite collection of servers. In this case, it happens to be blades, switches, both fiber channel and IP switches, and then storage arrays to support the virtual machines that run in that service core. And so again, as capacity is used up, the service cores are replicated in the cloud provider's site. Another component of this, I'll touch on it briefly in a minute, is encryption of data. A service core is very amenable to doing encryption of data based on fiber channel encryption. And so in this particular case, there are Brocade encryption switches that encrypt all data at rest in each and every service core. And so it's an ideal way to do encryption. You would use an encryption key management package. RSA is the most popular in that space, to control the encryption of all of that data. And I think I just talked right over that slide. And so the purpose of this slide is really to talk about that concept. And so SAN-based encryption model is very flexible. It does not depend on applications. It allows for encryption to occur transparently, and also provides a relatively low overhead. All encryption obviously adds overhead to the disk I/O, but SAN-based encryption, particularly from Brocade, has very low overhead associated with its encryption. And so again, it provides an element of structural security. You do not have to be concerned that a service tech who comes in and replaces a disk drive leaves with your information. And you will hear providers provide policies. Well, each drive, when a drive is serviced, it's destroyed or it's degaussed or there's something. But in each case, somebody has to do something for that to occur. And when somebody has to do something, there's always a chance that they don't. And so if you take a data at rest encryption approach and insist on that for your providers, it doesn't matter whether this thing is physically destroyed or degaussed or any other way. If somebody just literally takes it out and goes away with it, there's no useful information they could ever extract from it. Generally, what you'd see on top of a service core model is something, for lack of a better name, a cloud management platform. It's all the software that manages the customer experience, manages the service cores underneath of that, and most importantly, provides all the automation associated with provisioning, from bare metal provisioning right through to the provisioning of virtual machines, and then all the services that a virtual machine needs. And so obviously network provisioning, storage provisioning, server provisioning, all of those things, the automation layer exists in all of this. From a security point of view, I've talked about different pieces of security. So we talked about about 3 elements of structural security: the ability to project virtual machines onto the customer's network, the ability to have an isolated portal, a separate portal, a unique portal for each customer. Also, the idea of making sure that all data at rest is encrypted. But you also need to look at the other types of security that they provide, the traditional layered security, the way firewalls are deployed, both virtual and physical firewalls. How is that done? Who controls all of that in terms of the configuration of those things? But it also should include some type of third-party monitoring capability. And so what I mean by that is a company that is engaged by the cloud provider to monitor their security infrastructure 24/7. And in the event of any security intrusion associated with that infrastructure, not only notifies the cloud provider, but notifies you. And so even if your virtual machines are uninvolved in whatever the security issue was, clients have an absolute right to know that there's been a security issue associated with that center. And and they should not need to depend on the cloud provider telling them that. I mean, because obviously, sometimes those messages are not conveyed. And so a third-party monitoring company, guarantees you that if there's any type of security issue, you'll know about it at the same time that the cloud provider knows about it and can respond in whatever way makes sense for you. We've talked about the connectivity associated with all of this. The SONET connectivity is an absolute prerequisite. A cloud provider who does not offer, SONET-based connectivity and all the private line extensions of SONET connectivity can never properly host production applications. Again, because as we spoke earlier, because of bandwidth restrictions, because of latency restrictions. And so again, a simple internet connection might work fine, may even work fine for some production applications. But if you're going to be serious about putting production applications into the cloud, the provider really has to provide you professional grade communication capabilities. And so you would expect a provider to provide a very large OC768 bandwidth capability from their center and a variety of ways to attach you to their SONET ring. I think the types of connectivity that we've already discussed, is probably one of the single most important differentiators. The ability to attach through all of the through MPLS, through Metro Ethernet, through Internet, through other overlay services. In addition, the provider should be using multiple SONET rings, simply because even as resilient as a SONET ring is, there can be outages associated with a SONET ring. And again, if you're running production applications, particularly mission-critical applications, you'd want to have the option of actually attaching to two different SONET rings, and preferably two SONET rings that are not running on the same LEC in your area. And so if your SONET ring is provided to you by two different telecom companies in the same area, it is very likely that one of them is running on the infrastructure of the other, because typically there's only a single LEC in the area. And so it's important for there to be whoever the major supplier of cable SONET ring in that region be the second SONET ring associated with that. If it's a cable company SONET ring, they typically do not run on the LEC in the area. They have a totally separate infrastructure and can provide you that that kind of redundancy in a way that you can be sure that the loss of any part of the SONET ring does not affect both rings simultaneously. This is important in general, but I think even more important in a production application. The ability to move virtual loads in and out of the cloud, either from your own virtual infrastructure, from another cloud provider, or for whatever the reasons you need to move virtual machine loads. It is very important that your cloud providers support the open virtualization framework. It is the one way you can be sure that you can move virtual machine loads transparently from provider to provider, or from your own infrastructure to the provider, or vice versa. And so, this is, again, a key differentiator for a production-ready cloud, is that they're going to give you these capabilities. So they're going to make it very easy for you to upload your own OVFs, make it part of their service catalog, so that they can simply, you can simply move virtual machine loads at will for whatever reason. And also, if you're dissatisfied with your cloud provider, for whatever the reason might be, it makes it very easy to extract yourself from that cloud provider and move to another one. So there has to be that kind of portability between your infrastructure, your cloud provider's infrastructure, and any other cloud provider that you might want to use, either as a replacement for the one you were using or in combination with the one that you're using. So we've talked a lot about all of these 5 categories. The thoughts that I'll leave behind with you, around security, is the concept of structural security, layered security, and third-party security monitoring to create a complete security package. Connectivity, we've talked about the need for SONET connectivity and all the types of services that can be run over the SONET in addition to traditional internet connectivity. From a resilience point of view, that infrastructure needs to be built to mission critical standards. And what I mean is there cannot be any single points of failure in that infrastructure. The migration considerations we just talked about, it is vital that it be an OVF compatible service so that you are not locked in any way, shape, or form to that cloud provider and can move easily in and out of that for whatever the reasons are that you need. And finally, it is important that the infrastructure itself be a next generation design, what we talked about earlier, a service core based design. The very nature of a service core based design provides much more predictable isolation of customers, much more predictable performance, and allows the cloud provider to augment their capacity transparently. Since each service core stands on its own, when you add another one to the floor, there is no chance for it to disrupt anything else that's going on in the data center. If you're using a more monolithic infrastructure, well, adding to it, there's always risk associated with that, with that activity. A service core based design eliminates the chance that in the normal capacity management and in the creation of new capacity that they could interfere with something that you are doing. So we have a few minutes left. I wanted to see if there are any questions from the audience.
If you raise your hand, I'll come running over with the microphone so we can actually hear it.
Henry, first of all, I want to say that I'm enjoying your presentations.
Oh, thank you.
Could you elaborate a little bit more about what's required from the applications? Because nothing prevents you to put unencrypted data behind the firewall, and you can have greatest infrastructure, but anyways, it's not secure.
So, in the case of the design that I talked about, the mere fact that the virtual machines are projected onto your network, secures what goes on inside that server. And so if the virtual machine is projected onto a segment of your network, the cloud provider can't see inside of that virtual machine. And so along with that and whatever firewall strategy that you want to do, you can be very sure that the cloud provider cannot see what you're doing inside a virtual machine. And at the same time, if a cloud provider is providing for encryption of not only transmitted data, but data at rest, you also know that there's no way for the cloud provider to look inside the data as it exists in the file systems. So between those two things, you can provide a very locked down environment.
We have another question over here, Henry.
Okay.
Oh, the other side.
Where are you, Jen? I see you. Okay.
Hi, I'm assuming you guys are hosting tier 1 or mission critical applications in your data center, right? Can you give us a couple of examples, like what are the top, 3, 4, 5 applications you guys are hosting in there, or what are the trends there?
Boy, it is a very diverse collection of applications. So we have customers who deploy ERP systems. So for most companies, particularly manufacturing companies, it doesn't get more mission critical than that. All the way down to to hosted email. For a long time, we never thought of email as a mission-critical application, but just let your email service be down, and you'll find out how mission-critical it is. So, typical data analytics applications, ERP, any type of traditional 3 or 4 tier client server application, you'll see deployed in our cloud because it's amenable to that. So there's a very broad selection of production applications that people have chosen to put into the cloud. I would say the one that you do not find in our cloud is large-scale data warehousing. Because of the current limitations around number of virtual machines in the hypervisors, you can't build very large-scale database servers typically required by data warehousing. So it's there. It's not there because of performance reasons, but as those limits increase, VMware 5.0 expands the number of virtual CPUs out to 32. You'll even start to see data warehousing applications.
One follow-up question. Do you see your data centers or your sources being used for DR purposes a lot, or what do you see the trend there?
It is very commonly used for that. Particularly by small and mid-sized businesses. If you talk to the typical small or mid-sized business, in general, they're not all that happy with their disaster recovery scheme. At best, is some type of shared pool of equipment, with a DR provider that is extremely difficult to test, is not likely to come up quickly in the event of a disaster. But if that same small or mid-sized business has virtualized their applications, they can fail those loads automatically into the cloud. They can do so at a much lower price than you can from a typical shared pool DR site, and you can test it at will. And so it is probably as common to use DR as people, to use it as a DR site as people who are using it for virtual machines to actually run the normal applications or the day-to-day applications. So that type of DR targeting, has become a very large part of our installed base.
Any additional questions? Just raise your hand. I'll come running over. All right. Well, I'd like to thank you today. Thank you, Henry.
Thank you, everybody.
Thank you, Henry Fasta.